Hello there and welcome to the February edition of the Manitowoc Ice Monthly Spotlight. My name is Jason MacDonald, Technical Service Trainer here at Manitowoc Ice. And today we're going to talk about the Koolaire series of ice machine and its safety limits. So let's bring that presentation back up on our screen and we'll get going. As we do on all of our spotlights and on the predecessor of the webcast, there will be a quiz at the end of this seminar that you can take on your computer or on a mobile-friendly device. There'll be a QR code and a URL link that you can use at the end of this presentation. Thank you. So we have three safety limits on the Koolaire ice machine, the modular Koolaire ice machine. The undercounter is a little bit different. Today we're talking about the machines that will sit up on bins or on ice dispensers. So revision 3.2 software or later for the Koolaire. You can find your revision on the sticker on the control board. It'll say SW, a colon, and then the revision with a 3.x. We're saying 3.2 or later. If your freeze sequence reaches 35 minutes, 3 consecutive times, we're going to save that safety limit in the memory of the control board and flash the safety 1 light at 1 second intervals. If you have 6 consecutive 35-minute freeze cycles, the machine will shut down, lock out, and then the safety limit 1 light will be lit solid on the board. So, things that can cause our issues. A water pump being out of alignment or a water pump that cannot move water will lead to a safety limit 1. We'll get into why a lack of water is not a reason for this, but go ahead and check while you have water in your water trough and power to your water pump, 115 on a 115 volt unit or 208, 230 on a 208, 230 volt, 60 hertz single or 3-phase system. If you've got a trough full of water indicated by the low level float and high level float lights on the board being lit and power going to the pump, if you do not have water going over the evaporator and there is not a restriction in the pump screen or in the tubing going up to the distribution tube, you would have a defective water pump. If we cannot pump water over the evaporator, we will not transfer heat out of that water and freeze it into ice. A stuck open water inlet valve will lead to a long freeze. You got to remember with the Koolaire model ice machines, we don't sense ice on the evaporator, we sense water in the water trough. So a overfeeding water inlet valve or a water supply that is greater than 80 psi, preventing that valve from seating, will continue to fill our trough, which will then make us never run out of water. Well, if we don't run out of water, the low-level float will not come down, it will not initiate a harvest, and will stay in freeze for that 35-minute maximum. So, defective water inlet valve, not flowing, not letting the right amount of water come in, improper GPM, too much water pressure, stuck open valve, all of these things will lead to a safety limit 1 from getting too much water. Float switches, however, can also cause an issue. You got to remember, we have 2 floats. We have an ice thickness float that'll tell us how much water we have and if we need water. And we have a harvest float, which its job is to tell us when we're out of water and therefore it's time to go into harvest. A stuck, closed, down position float will lead to a situation where we run out of water, we do not get the signal to the board, and we do not go into a harvest. So remember, when the ball is up, it is an open circuit and the light should be on. When the ball on that float is down, it is a closed circuit and the light should be off. Here we just want to highlight that you can ohm out these floats. Consistency is key, so down, close switch, somewhere less than an ohm, and consistency. Consistency is key. You don't want to see that ohm value dancing all over the place. 0.5, 1.5, 0.1, 0.3, 0.7. Typically, you're within a couple of tenths of an ohm as you go open and closed, open and closed. And when that goes up, I want to go to OL or infinite each and every time. Consistency is key. So if you cannot get consistency or you're ohming out of spec, go ahead and replace that float. Could also have something going on with your harness itself, but you could figure that out by jumping at the board. Another electrical / refrigeration issue that you could run into is the high pressure cutout switch. If you look in the back half of your Koolaire Technician's Handbook and find the wiring diagrams for the modular Koolaires, you'll see that that high pressure cutout switch does not tie directly to the board. We go from the board to the contactor, but we have to go across that high pressure switch in a closed state. If the high pressure switch opens, the ice machine will continue to run and freeze without the contactor being pulled in and without the compressor, and therefore without the fan on an air-cooled unit or without water passing through the water-cooled condenser until that pressure switch resets itself. If this keeps happening, whether it's because of an actual high pressure event, which on these 410 systems will happen at 600 PSI, or because of a fan switch that's not cycling correctly, causing us to continue to rise and rise and rise on our head pressure, we're going to end up having a long freeze. So high pressure events on the modular Koolaire ice machine could lead to a long freeze. But what about the refrigeration system? Truly the refrigeration system. I'm not going to go into all of the ins and outs of refrigeration on this spotlight, but we have talked about how to follow your symptom 2 checklist. That's the long freeze checklist. All the components that we have up on this screen right now, the compressor, if it was inefficient, the hot gas valve, if it was leaking by, or the expansion valve starving, could all lead to a situation where you would not make ice within that 35-minute freeze cycle, within that 35-minute maximum freeze time. So if you are dealing with these situations where you've been in freeze double or triple the amount of time or close to that 35-minute mark, you've justified the need for gauges, and you need to start looking at things like your charge. Again, remember, the only way to truly know what the charge in a system is to pull out whatever's in that system and weigh into the nameplate charge. If you pull out less than what's in that system on its data tag, you want to start searching for a leak, find it, repair it, charge it back up and reevaluate. Otherwise, go through your symptom 2 checklist and you'll be able to figure out, do we have a compressor problem, a TXV issue, a charge issue, or a hot gas valve issue. Safety limit 2. So we've been doing safety 1 and safety 2 on a lot of our machines for a lot of years. Safety 1 that we just covered was long freeze. Safety 2 is our long harvest. If the harvest sequence on current versions of software reaches 7 minutes, 3 consecutive times, we're going to de-energize this each time and go into a pre-chill every time that happens. So the difference between it and indigo is every time an indigo has a 7-minute harvest, it goes into a thaw sequence. After 3 consecutive 7-minute harvests, the machine is going to save the safety limit into the memory of the control board. If the maximum harvest time has been exceeded 100 times on this Koolaire, the machine will shut down and it'll light up the safety 2 LED lit on the control board. The machine will just be sitting there doing nothing with the toggle switch in the ice position until you turn it off, turn it back on, and start troubleshooting your harvest issues. So what are a couple of things that we look at for long harvest? Well, we have 2 symptom flow charts for a long harvest. We have symptom 4, where the ice machine will not harvest, but the freeze cycle is normal and we are melting our cubes. In that case, we're not looking at a refrigeration issue. If you can make a full sheet of ice for your ambient conditions and your water temperature coming into the ice machine, and you're able to melt that ice and not drop it, you've got enough refrigerant in the system and you have a device that's metering correctly. But one of the things we like to look at in harvest, during the first 45 seconds of harvest, we do what we call the harvest purge. So the dump valve, the harvest valve, and the water pump are all energized. If for the entire 45 seconds of your harvest purge, water's just going over the evaporator, the odds are the dump valve is either not letting water pass through, or the drain line downstream is clogged up, not letting water pass through. So verify no restriction in your drain line. If you still can't drain any water out, you're looking at a faulty dump valve. You need to replace your dump valve. But what if we had a symptom 3 or a refrigeration problem going on as to why we're not harvesting for safety 2? Hey, we made great ice, but we're not melting even a little bit. Well, you might not have enough room to go straight to the valve. So there is a way you can check, is the board even sending power out to that valve? Well, the easiest way to do that is find wire 56, which is going to be common to all of your devices. It's typically going to be a white wire, 56, and wire 61, which is the L1 to your hot gas valve. In the case of a dual circuit evaporator, 48-inch wide, it would be the L1 to both your hot gas valves because they'd be wired in series. So if you push 1 meter lead up against wire 61 and the other one up against 56, and you have your line voltage in harvest, then you know Board is sending power out, valve is receiving it. But what happens if our pressure profile doesn't match? Well, a restricted hot gas valve, regardless of if it's a traditional hot gassing harvest or a cool vapor defrost like you'll see on the Indigo CVD systems, your head pressure will be higher than what's published for your ambient, and your suction pressure will be lower than what's published for your ambient. High head pressure and low suction pressure during harvest with power to the harvest valve will be a restricted hot gas valve all day. You'll need to cut out the harvest valve, cut out the dryer, braze in new, pressurize the system for leaks, recharge to the nameplate weight, and you'll be back to harvesting ice the way you were supposed to. But it doesn't hurt. Let's say you do have room to check the valve and the board. What if there's a wire issue where something's loose, causing us to have voltage coming out of the board, but not voltage getting to the valve? Could be a wire break somewhere in there. That's going to be hard to figure out and hard to trace. But if you see that you've got power coming from the board across 61 and 56, but no power at the valve, you may have something loose in the bulkhead harness, and you're going to need to be able to troubleshoot that issue. Lucky for all of us here, the compressor compartment wiring harness is available. It's a plug that goes into the wall and then has plugs for each of your output devices. In the case of the Koolaire, the dump valve, the inlet valve, the water pump, the harvest valve, and the contactor. Again, we did highlight how to diagnose a hot gas valve issue, but you might be working on an air-cooled, a water-cooled, or a traditional remote. To really get to the bottom of it, you're going to want to follow your symptom 3 flow chart for the air and water cooled, or the symptom 3 flow chart for the traditional remote if you're working on a traditional remote ice machine. Safety limit number 3. So we've seen the board a couple of times here. There's only 2 safety lights. You have a safety 1 light and a safety 2 light. But I just told you there are 3 safeties on our board. So the safety limit 3 for this machine is the water loss or no water safety. Should you not get water to fill up and lift up the harvest float within 4 minutes of the water inlet valve energizing, what's going to happen is we're going to shut the machine off for 30 minutes and we're going to try again. Then if it happens again, we're going to shut off for 30 minutes and we're going to try again. And we're going to keep doing that until it's gone on 100 consecutive times. At that time, we're going to shut the machine down and light up the safety 1 and the safety 2 lights. On initial startup, if you have a safety 3 in the memory of the control board, if you toggle off and back to ice, the safety 1 and 2 lights will flash in unison 3 times to let you know that you've had a water loss or no water safety event. 3 blinks of both lights lets you know safety 3. 1 plus 2 equals 3. But why do we let you get the 100 times? Well, maybe the city has been doing a little bit of work and had to shut off water to that block, and they finish up in a couple of hours. Well, if you do a lot of that math, 100 cycles with 30-minute delays in there, that's more than 15 hours. Hopefully, they turn the water back onto the building, and the ice machine is able to kick it up and running. But what happens if we do have something wrong with our water system? Well, if we've got a plugged up water inlet valve, a water inlet valve that does not open mechanically, or water pressure coming to that machine at less than 20 psi, either because the water pressure just fell off or because we have a water filter that needs to be replaced. If we cannot let water through that valve into the trough to lift up the float within 4 minutes of the inlet valve energizing, we're going to have a problem. So to verify, you're going to want to check, does water actually come to the machine? Might have to unplumb it, get it into a bucket, and see what happens to you. If it can come to the machine but not through the valve, then we know that the valve is going to be the issue. You're going to need to go to your local Manitowoc ice distributor and give them the model and serial number of your machine so they can get you the correct water inlet valve. We do have multiple valves for multiple voltages. A stuck open or leaking dump valve can also lead to this issue. If that valve is leaking by quite a bit, where we can't bring water in fast enough because we're losing it at the same time, that can lead to a safety 3. Could also lead to a safety 2 if it's barely leading by, where we satisfied those floats, but then we lost the water as we're making the ice. But we're talking about safety 3 right now. So if you really want to see is the dump valve leaking by, go ahead and check across it with your meter while in freeze. So you should see the compressor relay lit and the pump relay lit. That'll let you know you're in freeze. Go ahead and check for voltage across it. If you're not reading your 115 or your 208 230 on a machine that is 208 230, then you know that it is not electrically being powered by the control board. Go ahead and pull the outlet off of that dump valve and see is water trickling by. If it is, and it does not have power, you have a leaking dump valve. Turn the machine off, take the dump valve out, try to clean out the innards a little bit, and reevaluate. If it's still leaking by, shut the machine down, go to your local part house, and get yourself a dump valve. But float switches, remember, when the ball is up, the switch is in an open state, and when the ball is down, the switch is in a closed state. Right there on the screen, what you'll see is the high-level float light is lit, but the low-level float light is not. Well, the high float light indicates that the ice thickness float switch is satisfied. Well, the ice thickness float switch sits higher than the low-level float or harvest float, so this is physically impossible. But if we have a float that is electrically stuck open, well, what's going to happen is we're never going to fill with water. We're going to go into pre-chill. The ice machine is going to be told, hey, I don't need any water. The board's going to say, all right, you don't need water. I'm not going to send any. But then we're never going to see the low float satisfy. So a stuck open, whether it's just because the ball is stuck up because it's dirty and needs to be cleaned, or because there's an issue with the float, or because you cleaned it and you put it back together backwards, could lead to a safety limit 3. What you see here on the screen is impossible. Go ahead and clean the float, verify that the float is not upside down. These Koolaire floats does have up written on which side is supposed to be up. It doesn't have down written on what side is supposed to be down, but it has up written on what side is supposed to be up. I'd like to thank you for joining us all today. Love doing these spotlights and the webcasts. In March, we're going to talk about discharge pressure and how it has an operational impact. We're also going to talk about the April series for the USC 50, or Crystal Craft Premier service limits. In May, we're going to talk about Indigo and Indigo Next control board LEDs and what they mean to us. The green LEDs for the input devices and the red LEDs for the output devices. And then in June, we'll talk about Neo and Koolaire control board LEDs. Those two machines, they share a board. So we're going to talk about that and see what happens there. Again, thank you for joining us, but I do need more ideas. You see that I only went through June, everyone. I need something else to do in July, August, and as we keep going. The rest of the training department does, the rest of tech support does. We need your help. Scan this QR code and we'll be able to take your ideas. If it's something we think has a great amount of value, we'll probably give you a shout out. At the very least, we'll make it and you'll have some new content for you out there. So I'm going to leave this up there for a minute. But again, we talked about how there's going to be a quiz. It will be mobile friendly. Also want to give a shout out about our factory schools. We're almost done with this season. If you go to the website now, you'll actually see that we've got the fall schedule up. So this slide's going to have to be updated for you guys going forward. But go ahead and look at our factory school schedule, see if it's something you want to register for. There is now a Snowflake click here link for registration. You'll be able to fill that out, send it into the email provided on the website, and we'll be able to sign you up for our schools. 4.5 days worth of factory level training, classroom and hands-on. But in order to receive a copy of the presentation in a PDF format and a certificate of completion, we're going to need you to fill out all the questions, answer them all, provide an email address so we know how to get in contact with you, and click submit. If you miss any of those steps, we're going to have an issue getting you that information. And we're still doing our swag bag prizes, everyone. So if you take the quiz before the next monthly spotlight airs, we will draw a name. One name for every 25 people who take that quiz, and we'll draw out a winner. We'll give you this swag bag. It's got a hat, a nice little tote there. We've got some Band-Aids, a letter opener, some lens cleaner, and a tape measure. So go ahead and take those. Let's try to get ourselves to 50 or 100 and make me send out 4 of them, make training send out 4 of them. Since I'm the one giving the presentation, I'll probably do it for this one, but you know what? Jared might do it. Someone else might do it another time. So let's go ahead and get those quiz submissions into us. Again, Manitowoc Ice loves to provide training. I hope you enjoyed your presentation today. As you watch it on our YouTube channel, please like and subscribe so you can get notifications of when we do more training in the future. We're going to leave this up here so you can copy that link into your web browser or take a snapshot of that QR code to take you over to the mobile-friendly quiz. Good luck on your quiz. Good luck with your field work. Thank you for attending.